This is part 5 in a series of narrated videos where I'm going through the exact same exam questions as in the GCSE Science Sprints series of shorts, but I'm just talking them through a bit more slowly and explaining my thought process, which I think is particularly useful for these chemistry calculations. In the first chemistry video in this series, I warned you that it's really important with these quantitative chemistry questions that you establish what type of question it is before you start, so that you don't get really stuck in and then realise you've wasted your time doing the wrong kind of thing. So in this instance, we've only been given the mass of one reactant. In fact, there only is one reactant, and we're trying to work out the mass of a product. So this is what we call a theoretical yield question or a reacting masses question. It's not a limiting reactant question like we had in the previous video, because then I would have been given the masses of two different reactants, which here is impossible. So now I've established that, before I get into the calculating, I want to do a little bit of housekeeping, because it's really common to see people panic under pressure in the exam and use the wrong mass for the wrong chemical, or to work out the mass of the wrong thing. So here they might work out the mass of sodium instead of the mass of nitrogen, and we don't want to do that. So before we get started, I'm going to write 32.5 underneath the sodium azide, and write a question mark under the nitrogen and cross out the sodium so I remember I don't need to do anything with sodium. Now, for these quantitative chemistry questions, even if you have a panic and you forget the whole process, because some are quite long and extended, there are almost always marks available for working out relative formula masses and numbers of moles. So even if you forget everything else, start there, get yourself some marks in the bag. So our relative formula mass of sodium azide we find by adding together the relative atomic masses of all of the atoms that are in it. So we've got 23 for sodium, there's only one sodium, 14 for nitrogen, there are 3 different nitrogen, add it all together, we get 65. So now I can pull out my old friend, mass is Mr. Mole, and we can rearrange that to be mole is mass divided by MR. So the mass is the mass from the question. I know it's a mass because it's in grams, and we're dividing by that relative formula mass of 65 grams per mole that we just calculated. So that gives me a total of 0.5 moles. And you'll see as I've gone through here, I've kind of indicated what I'm doing at each stage. So I've said MR equals, I've said moles equals. And the reason that it's important to do that is that really often we make mistakes when we're under pressure. But if your examiner can see that you think this number that you've just written down is the number of moles of sodium azide, then if you've gone on and done the correct thing with that moles, even if your actual answer at this point is incorrect, you can still be given credit for it. But if you've just written down the number 0.5, well, that will be fine because it's right. But say if you'd written down 0.6 and then you just kept going without saying this is the number of moles, then we can't give you those follow-through marks. So that's why it's really important to annotate your calculations like this as we go through. So now we need to know our moles of nitrogen. And that's not going to be the same as the moles of sodium azide, because as you can see, for every 2 sodium azide, we make 3 nitrogen. So some of you are looking at that and going, right, it's 50% more, great, I can do that, that'll be 0.75. Some of you are not that confident with maths, but also sometimes we're not going to have numbers that are just this nice. So the kind of long form way to do it is look at the coefficients in that equation, because they're telling you what the reacting ratios are. And what we're going to do is divide by the coefficient in front of the thing we're already confident about, and then multiply by the coefficient in front of the thing we're trying to work out. So in this instance, we're going to do 0.5 divided by 2 multiplied by 3, which does of course give us 0.75. Happy days. But we don't want the final number of moles, we want the final mass. So again, we need to work out an MR. This is really simple because it's just 2 nitrogens. So that's going to be 14 times 2. And then we can put that together with our masses Mr. Mole to say 28 times 0.75 gives us a final mass of 21 grams. And I've listed it as 21.0 because the original mass that I was given was to 3 significant figures. So my mass here should be to 3 significant figures. Now, if AQA want you to do that, they will tell you to do that. They will say, give your answer to 3 significant figures, but it's just a really good habit to get into, particularly if you're going to go on to A-level where they're not going to give you that instruction, that you should always be giving your answer to the same degree of precision as the data in the question. Thank you very much for watching, and I hope to see you again on Friday for the next physics part of this series. If you have found it useful, then don't forget to like and subscribe, comment, tell me which topics you want me to do next, and also share the channel because it helps it to grow. And I'll be back soon with some more GCSE Science.